Okay, let's do it. Let's go to jump game 2. Okay, 9 out of 150. Okay, this time I'm gonna start the timer. I've forgotten it every single time now. Okay, let's see. Same as last jump game. Oh, so this part is all the same, but now we want to return the minimum number of jumps to reach the last element. So last time we just need to return true or false if we are able to or not. And now it's guaranteed that we are always able to reach, and now we want the minimum number of jumps to reach the last element. Minimum number of jumps to reach the last element. Okay, so first idea is that we will record all of our different ways to reach the last element and how many jumps it takes, and then we return the minimum number of those. I'm sensing that it's not very efficient. I wonder if there's a better idea. Okay, let's see the examples. So we have 2, we can go here or here, but if we just jump once to here, then we can jump to the end. But if we had jumped 2 steps, and that would be 1 step, and then 2 steps, and then 3 steps. So that would be less ideal than just jumping 1 step here and then 1, 2, 3, 2 steps in total. So minimum number is 2. Okay, what about this? Let's see, it can go here or here. So this is a no-go because, I'm getting messages. So if you're ever staying at 1, there's nowhere to go. So you have to jump to this one and then you jump to the end again. Okay, it is guaranteed. All right, let's think. So for the first example, we had 2 different ways to go. We can go here and then there. We can go here and then this. We could actually also go 2 to 3, and then instead of jumping 3 steps here, we could still jump 1 step and then 1 and 1, or jump 2 steps to here and there. So I'm thinking that it wouldn't be the best idea to somehow record every single way to jump and then get the minimum number of jumps. Is there some smarter way that will help us to get the minimum number of jumps? Minimum number of jumps to reach the last index. So last time for jump game, we were doing something like this, and then I is the index and nums I is the maximum number of steps you can go from that index. So that was like the core concept last time. we are constantly tracking, we are traversing it once, and then for each element we are tracking how far it can go, and is this farther than the last farthest. If it is, then we can go farther now, and then we see if we can in the end reach the last element. Number of jumps to reach. Okay, so if we do something similar, what if we do, okay, we do this, and we can either go here or there. That'll be one more step. Okay, so it takes one step. Okay, so when we are here, we know that it takes one step to go as far as this. And when we are here, we can go all the way to 4. Then we know that it takes 2 steps to reach this. Okay, we need a better example. Let's give it some more steps here. Let's say 2, 0, 1. Okay. So we start from the first element, and then we know it takes minimum 1 step, 1 jump to reach this element. And then we are doing this, and then when we're here, we found out that the farthest we can go is here now. So that means it takes minimum 2 jumps to reach this. And then we go here. This is not gonna be farther, so it is not gonna bring us closer. So that same thing. Okay, so it takes minimum 2 steps to reach this 4, and now we have this 4. We're at 4. 1, 2, 3, 4. We can reach this. That means it takes minimum 3 jumps to reach this. We need to consider some other cases. Let's change this 4 to just 2. That's good, because then we'll end up at this 0, so we will be forced to take the 1 step and then take this 2. Okay, so let's consider this example. So still we need at least 1 jump to reach this, and then we need at least 2 jumps to reach this. And now we will need to use another jump to reach this one. Right. And then we need another jump to reach this or that. And when we're here, we need another jump to reach this. Okay, so that's the idea. Let's try that and see if that works. Let's say we have minimum number of jumps. Minimum number of jumps, mean jumps. Okay, minimum number of jumps, let's start with 0. Okay, what if we go through the entire nums? So let's just use this example. So we are at 2 to start with. The farthest we can go is 0 plus 2, so that is 2. Okay, we'll need something like if farthest reaches the end of it, then we need to return main jumps for now. Okay, so otherwise we calculate the farthest, and that will be 2. And then we go to the next one. So when do we increment the mean jumps? Is it so that every single time we reach a farthest, is that when we increment? Let's see. So first farthest is here. Next time it crosses over would be one more step. So 2 jumps, 1 jump, 2 jumps, 2 jumps here. Next time it goes over, okay, we have another jump. Need to handle this 0 to make sure that if we end up at 0, then basically that's not gonna count as the farthest. Okay, let's try that. So let's try with each time we have a bigger farthest value, we increment the minimum number of jumps, and if we end up somewhere with 0, we basically ignore that. We do not count that as farthest, and we do not count that as crossing it and taking another jump. Okay, so let's try that. Farthest is that. Okay, if and if that's not 0, so if it crosses the farthest farthest end, we do not end up at 0. Okay, that's not gonna work, because if we're standing here at 2, it does cross farthest, but that will end up at 0. But we still wanna consider the case when it doesn't take the entire 2 steps, it just takes 1 step. I mean, I'm thinking of something that's probably stupid, but I'm thinking of something like, if so we're still considering this, we are here, what if we do something like, well, what if this is 0? What do we do if this is 0? Then we wanna decrement. Oh my god. Well, this is 0, and I mean, we are at I, so j needs to be bigger than I. So we are here. We can consider these two. So when this is 0, we decrease by 1. So we are now at this 2. So farthest would be J. What if this also was 0? What if okay, let's like temporarily, let's say it's 2, 0, 0. So first we were there, then we decrement, and then we have 0 again, we decrement. And now we are out of the while loop, and we should actually stop now because there is nowhere to go. So on the next round we have 0 and farthest we have if I so oh wait, okay, so we don't even have these cases because oh my dinner's ready. We don't it's beeping. Okay, so we don't even have these cases because it's guaranteed that we will reach the end. Yeah, so we can ignore that, but just in case we do have those cases, what we would want to do is, if we are here at I and the farthest we can go is here, then we actually cannot reach the end. Basically, we need to break out and just return, but we don't have these cases here. Okay, so to this. So what do we have now? If it reaches the end, we wanna return if this is jump over to the farthest. When it crosses farthest, we wanna get the farthest it can go, the index for that, and consider the cases where there were 0, and then we set the farthest to that index and we increment the minimum number of jumps. We wanna return the minimum number of jumps. We are probably missing some cases, but that's what I have so far. Let's see. Oh, I'm glad that's working for these 2 cases at least. Okay. Oh, I see. This index out of range. What is... Okay, we have 2, 1. Oh. 2, 1. So we're starting here. If do we wanna do something like this? Let me see. That's the... Okay, so the farthest we can go is at 2. Okay, let's try that. Oh, that does not work. Okay, let's see. So we have 1, 2, 3. So what if we... Okay, to think about this. Well, so we have J would be 2, farthest will be 2, mean jumps will be 1, and the next round I. 4. Why is it that they did not come in here then? Okay. one. So if this already reached the end, then we just need to go here. So that's where I had it before. So before I had it like this. Okay, let's actually go back to what I had before, because I feel like it's messing up quite a bit now. Okay, so if the farthest is reaching the end, we return. Otherwise, we are doing this. So what was the problem with this again? Okay. I mean, this would okay. Well, let's just add it in here. The other way didn't work. Okay, so we want, I'm not even sure if new to Python, so I need to look it up if we can do this and that and j is smaller than length of nums. I will okay, apparently that and the end is okay. Can I have multiple and in Python? Oh. Okay, promising at least it's past about half of them. Oh, I see. Oh, this is not good. Output is 7, expected is 3. Okay, let's look at this example. Very interesting though. It's already 30 minutes. It's already failed. Okay, 2, 3, 4, 5. It can go all the way to this 0. Oh, I see. There is something wrong with this part. So right now it is just going to the last as far as it can go, and then it just goes backward and stops at the first that's non-zero, which is incorrect because we will not actually check all of them to find the farthest. Yes. Okay, so oh, wait. Okay, so wait, let's do this. So it's here, and then now J is looking at this. So farthest is here. That's correct. Okay. So it takes minimum 1 jump to reach this. So that's correct. Then we go to the next element. 2, 3, 4, 5, 6. Okay, it can go all the way here. And we start from this, and then we go to this 1. So farthest is not looking at this, and the mean jump increment by 1. So that's also correct. We now have two steps. Okay. Then we go to 3. It does not go any farther, so we just skip to the next round. Same thing. Then there, have the same thing here. 3, 1, 2, 3, and then we're at this. We're supposed to go to this and end our result. Why does it not do so? Okay, let's just print this so we can see what it is. Let's and current. What else we want? We want to look at current index maybe. Let's see. Okay. So current index is 0, then current index 1, mean jump is 2. Seven. That's 7. When it's there, mean jumps is 3. 8. Okay, let's see. I want to see the farthest as well. Okay. Farthest is 9. So when we are at index 7, farthest is currently 9. Okay, 1, 2, 3. Here. That's not. Okay, so that's correct. So we're here, farthest is currently at 9. So why are we updating main jumps? Okay, so we updated it because this will cross the farthest. If J is not crossing the furthest, then we set that to J and we. Okay, let's see. Oh, okay. So we're still here. If J it is closer now, so I guess that's something. J is, let's look at J as well. So we are at 7 here again. J is 9. Farthest is 9. Then we are here. No update. Wait, when we are here, 1, 2, 3. Oh, I see. Okay, so when we are here, x8. When we are here at index 8, the farthest thinking of something like this, but not quite sure. No. Okay, not good. Okay, let's put that back for now, but what we kind of want is something like if is this something we want then? If this is okay, let's just check this logic. Oh my god. I wanna go eat dinner. What's going on here now? Oh, okay. I think I need to rest. We are back to this familiar case. Okay, so we are at 1, 2, 3, 8. We are at index 8. How many jumps should we have? 3. Okay, we are at index 8. We currently have 2 jumps. And oh, what if we? Okay. Oh no. Oh. Okay, let's go back to that. So when we were at index 8, we have had 2 jumps. We are jumping like this. 1, 2. And the farthest we can go is this for now. And what happens here? 8 plus 3, that'll be 11. So J is 11. J is J is bigger than farthest, which is 9. So now we set farthest to be 11. Mean jumps increment by 1. So why isn't it going? Why isn't it working? Oh, here, why is J? Oh, I see. That's because there are zeros, so they did not count that. So But this is, again, it did not work for the other case. If j is already bigger than the length, if j this does not seem to be like a real solution. It's just only gonna fix that one single case. Oh, okay. Let's see now. Output 4, expected 2. So we have 7. We can go all the way here. Then we have 7 again, so it goes all the way. So why isn't that jumping out of the loop right away? Okay, so when we are at index 0, j is 7, farthest is 7, we are there. Index 2, j is, I see. Okay, so I guess the logic of incrementing the number of jumps every single time it crosses the farthest, that's not correct. Because yeah, first time we jumped to here, and this we could have jumped longer, so it's gonna increment, but that's not what we want. That's not gonna be the minimum in the end, because we could have jumped from here directly to the end instead of jumping that 9. Okay, so I guess this whole logic is useless now after 48 minutes. I don't know if I should give up at this point. Usually it's good to give up if you can't solve it in an hour. So I guess we want to calculate. So okay, so first time we reached all the way to this 7, and then when we are standing at 9, we went all the way here, but we actually don't care about that. What we care about is, okay, after the first jump, which gave us all the way to this, then we just want to see the next time any element within these, the farthest it can go, that should count towards the next jump.